Hello guys. Now we go to another problem solving second law of thermodynamics. So this time is the standard change of free energy of the reaction calculation in a chemical reaction. So this one, okay, okay, like that. So calculate the standard, okay, free change or standard change of free energy for the reaction of ethylene gas plus 3 moles of oxygen gas is equal to 2 moles of carbon dioxide gas plus 2 moles of H2O gas. Okay, the change in the enthalpy formation of the reaction is negative 1323.1 kilojoules. Okay, and the change in the entropy of the formation standard of the reaction is equals to negative 29.7 joules per Kelvin. Okay, like that. So this is just a little bit easy because all are given, so we need to compute for this. Okay, so delta G or the standard change of free energy of the formation is equals to like this. Okay, delta change of enthalpy formation with the standard of the reaction. Okay, minus the temperature of the delta change standard change of free energy, standard of free, not free energy, but it's entropy. Okay, reaction. It is one. Sorry, okay. This is a standard. Okay, change of free energy. Okay, and the reaction is equals to the change of enthalpy standard of the reaction minus the temperature times the delta change of entropy standard for the reaction. So all are given in the problem. No need to, so delta HRX. The reaction is negative 1323.1 kilojoules minus temperature is 298. Okay, 298. Okay, Kelvin. Okay, so why 298? Because in this reaction, it should be automatic at 25 degrees Celsius. Okay, in this situation, not mentioned. If you try to compute the standard change of free energy, okay, multiply by, okay, entropy, which is negative 29 joules Kelvin. Okay, so cancel. So take note, kilojoules and joules is not compatible. So we need to convert either the kilojoules into joules or either the joules into kilojoules. So let's have joules and shot. Okay, so negative 1323 kilojoules convert that to joules. Okay, so 1323 kilojoules. Okay, 1 kilojoule. So 1323. Sorry, 1323.1 kilojoules. 1 kilojoules is equals to 10 to the 3 joules. Okay, so since that is a very high value of joules, kilojoules to joules, let's have the reverse. Let's have the kilojoules on. Anyway, it's just the same. You need to choose from joules or kilojoules. It's up to the choices of the, okay, on the question. the examination. Depends, okay? But here we need to have the less digits because of writing too much space. So it's gonna be, I like the, ano lang, kilojoules lang siya. So, in the entropy, we have, okay, 29, sorry, 29 times 298. So it's 642. So it's 642 joules into kilojoules. So 1000 joules divided by 1000. Okay? Like this. Okay, 29 naman siya. 29 na siya. Yes. 29 joules per Kelvin. Okay, so 29 naman siya. So 298 times 29. So divided by 1000, it's 6.42 kilojoules. So like this, cancel. So 1323.21 minus 8.642. Right? It's consistent siya. So the answer will be negative. Okay? Negative 1314, negative 13, negative 1314.458. This is joules. Oh, kilojoules, sorry. Convert naman to kilojoules. So our standard change of free energy of the reaction is equals to negative 1314.45 kilojoules. Okay, like that. Be sure that the units of the left and the side after the subtraction will be the same now, so that it will be green, or else it will become wrong answer. Like that. Okay. So negative is spontaneous. So this is a spontaneous reaction. Ethylene plus oxygen gas is equals to CO2 plus water. This is a spontaneous, is negative. So this is reversible reaction. So if you add CO2 and H2O, so it will come back to ethylene and oxygen gas. The oxygen gas doesn't participate in the change of free energy formation calculation. It will not participate. Only the ethylene, the carbon dioxide, and water. Because for the reason, oxygen gas has no value of enthalpy and entropy, because it will just dissipate alone, or monatomic gas. See? Like that. Okay, number 3, calculate the standard free energy change of a reaction for the same reaction above. Okay, like this. Okay. So this one's gonna be kilojoules per mole. So this is gonna be entropy, right? Entropy. Ganun ba siya? Yes, entropy siya. Or, I'm sorry, enthalpy. This doesn't mention, right, the number 3, calculate, but I think this is delta G of the individual. Okay. Standard change in free energy of the individual, not the enthalpy. Okay, it's understood because it's finding the standard change of free energy of the reaction mentioned. So this below is the standard change of free energy of individual compound. Okay, like this. So using the same equation above, so we can say directly as, okay, this is delta G, right? So you can say that gas products. I think we should do like this. So delta G of the reaction is equals to, but be sure first, guys, that the chemical reaction above ethylene plus oxygen gas is equals to CO2 plus H2 will be balanced first, because we need the number of moles to be multiplied by the change of the delta G in this number 3. Okay, so be sure lang yun siya. Okay, so summation of the number of moles of the product, which is the moles of the CO2 gas, okay, times the delta G standard of CO2 gas, okay, plus, okay, the summation of number of moles of water, gas, okay, gas also, sorry, and then times the delta G formation, standard formation of H2O gas, also like this. Here, puti kayo, no? But don't you worry, the subscripts are puti. Okay, but actually, if you understand, it doesn't matter also. Delta gas. So, number of moles of CO2 gas times the delta G standard formation of the CO2 plus another product is water gas. So, number of moles of water in gas state times delta G of standard of formation of water, like this one, so this one, minus the reactants. The reactants will be the summation of the number of moles of ethylene gas times the delta G standard free change of formation of ethylene. Then oxygen will be 0. Okay, oxygen will be 0 because it doesn't participate in the, in the free energy change reaction. Always take note, oxygen will not participate. Okay, so if you find another problem like this related to this, then there's an oxygen in the reactant, so it doesn't involve in the free change reaction. Always take note of that, because in here this is ethylene. Maybe in the next problem, this is propane plus oxygen gas, butane plus oxygen gas, methane plus oxygen gas, because this is an example of a combustion process. Okay, and then the number of moles will matter during the balance of chemical equation. Let's check first if it is balanced already. So carbon 2, hydrogen 4, hydrogen 4, carbon 2, oxygen 4, oxygen 6, balance. Balance immediately. This is very good because the problem is already given the balance equation. What if the problems will not give the balance equation? So you need to balance first because it's needed in the number of moles in the calculation of the delta G standard free change, delta G standard change in enthalpy, and standard change in entropy. The number of moles is very necessary to multiply that one. Okay, so you need to balance first the equation. In here, lucky because the problem is given the balance equation. So there's a lot of things to do. Balance the equation first, ganon, and then solve for the formula for that equation. And now let's substitute values na ta. Okay, I need another pa-page yun siya para makuha yun na ako. Chart. Sa tagsahon, pwede mag-ibo. Okay. Okay, guys. Okay. So number of moles of CO2 gas. Number moles of CO2 gas in the product is here. That is 2 moles of CO2 gas. So substitute. Okay. 2, right? Oh my God, it's very difficult without whiteboard to discuss something. You have to think, and then after that, you have to write, you have to analyze, and then Oh my gosh, there's a disturbance during the discussion. Sometimes I'm confused like this. Okay, so delta G R X N. Okay, okay, like this. Okay, so substitute values. So 2 moles now times the times here. Okay, here the standard free change of free energy of CO2 gas here. So this is negative 394.36 here. Okay, number 2 here. So substitute. Ganon. So 39, negative 39, negative 394.36 kilojoules. Oh my gosh, it's happening.
The Bluetooth device is ready to pair.
Kilojoules per mole. And then plus the number of moles of water, which is 2 also in the product here. Reaction at the top. Okay, so that is 2 moles also. So plus 2 moles multiplied by the water gas in this equation, in this formula here, presented here. Okay, so this is water is negative 228.59, the last one here. This is delta G of formation, like this. So we have negative 228 with 59 kilojoules per mole. So this is for the product minus the reactant in here, the number of moles of ethylene here, which is here, the reaction ethylene. So this is 1 mole of ethylene lang siya. Okay. So 1 mole ethylene because it is double band. So 1 mole times ethylene also here, that is the number 1 in the given in the problem, which is 68.4 kilojoules here. So multiply siya. Okay, 68.4 kilojoules per mole. Now cancel the mole. What will be left is the kilojoules. So do the basic simple mathematics for this. Okay, like that. Okay, ganun siya. So 2 times 228. So negative 456. Okay. Negative 456 kilojoules. Okay, and then the other one is 394.36 times 2 is equals to 788.72. 788.72, and that is negative siya. So, ganun. And then minus, okay, 68.4 kilojoules. So do the mathematics. This one, like this. You can have your own, because hugaw ang ako ang pagkasuwat. And you can have your own to make it clean so that you will not be undergoing errors, something like that. So negative plus negative is negative, right? So 788. Okay. 788. Okay. 0.72 plus 456 is equals to 124. That is negative. 1244.72 minus 68.4, and this is kilojoules, the unit. So plus 68.4. This is 13.12 negative kilojoules, this one. This is the answer of our, okay, so 1313. 1313. This is negative 1313.12. The change, the standard change of free energy of the reaction is negative 1313.12. So this is a spontaneous, negative man siya. Spontaneous reaction. So therefore, again, this ethylene gas plus 3 moles of oxygen gas is equal to 2 moles of carbon dioxide gas plus 2 moles of water is reversible reaction. Okay, it goes back to its original. If you reverse that one, still the same products will be obtained from the reactor, something like that. Okay, because negatives, ano man siya, spontaneous magud siya kay negative. Okay? Like this. So spontaneous pala, no need to add additional energy just to proceed the complete cycle of the chemical reaction. It will goes back and forth. Okay? Going to the product and going to the reactants, going to the reactants, and then for irreversible, no need to go back. Okay? Like that. It will goes back, then it needs more internal energy, or shall we say catalyst, or anything that is being the factor to make it reversible. Okay, because there's a lot, right? There's a lot of ways, especially the factors affecting the chemical reaction. Okay, if you can remember in chemistry, right? The nature of solute and solvent, okay, the temperature, the pressure, the catalyst. Okay, if you remember that one. So also this is also a factor. Okay, the negative, spontaneous, positive, non-spontaneous, like this, like this. Okay. So in here pala, we can really obtain the reversibility and irreversibility of the process of chemical reaction. So we can understand now. Okay. Aside from knowing the fact that it will not goes back to its original reactants, then we can also say by having this negative, negative standard change of free energy of a reaction. Okay, ganon. So that's it. Very easy, right? Okay. Just directly substitution and a little bit of, basic analysis language siya. Okay? And thank you so much for watching this live stream, short live stream of mine. And then if you think this video is beneficial to you and it adds you a little bit of learning information, then you can share to anybody else if you want. And then you can also comment to the comment section down below, or you can click the notification bell for some news updates on the MSC Journal Voice. If you are now subscribing my YT channel, it's up to you if you're subscribed or not. It depends on you. Thank you so much for watching. Okay, like that. Bye bye, and that's everybody. See you later. Nakakaloka. Diba?